After, which in MIT time is right on time. For those of you new to MIT, we start classes at 5 after. We're supposed to stop 5 before. So welcome everybody. This is a great turnout. How many people are full out registered for this class? Full out. All right. How many people are listeners? 1. Okay. And how many people are shopping? Okay. So, no, that's okay. I'm just trying to get a sense of where our steady state attendance would be, because I think I can probably accommodate most of this. We actually have another class project in our back pocket, just in case, a good one, in case we have to go up near 35 or so people. So, I'm not going to kick anybody out now, so you can keep coming. Welcome to Global Engineering. My name's Amos Winter. I'm a faculty member in mechanical engineering here. And this class is kind of the class equivalent of what my research group does, which is machine design and product design, but in developing and emerging markets. And I chose this picture as the first slide because this is me testing an all-terrain wheelchair in a village in India. And you're going to hear a lot about this wheelchair as part of the course. It's one of the case studies we do. But this is what I like doing. I like making products, making machines, and doing them in really unique socioeconomic contexts. So today I'm going to give you kind of an overview of what the class is going to entail. And then the last 30 minutes, Angie Lochnar, who's the library's representative to mechanical engineering, she's going to come in and talk to you about the specific resources that the library has set up for this course. So to start with some logistics, here's my contact information. And by the way, I'm going to post all of our lecture notes and our videos and everything on our course Stellar site. So you can find that. But you can go to Stellar and look up the course. But here's my contact information. Our fearless teaching assistant, looking very cool and windswept in this picture, is Michael Buchman, who's in the back on the video camera. Michael's one of my grad students who's been working with me now. This will be his second year. Our administrator is Kaki Hogan, and there's her contact information. And then each of your project teams that you'll be working with throughout the semester will have a mentor associated with them, and there's the list of the mentors. So to start off, why would we want to think about specifically how to design things, how to engineer things for developing and emerging markets? Like, why is that a different question than just machine or product design for the US or Europe? Well, there's a number of factors that make these markets unique, and I think they make them unique from an engineer's perspective, which is kind of what we're going to be exploring together. So the first thing is that there's a number of unsolved, massive global scale challenges that affect developing and emerging markets, but not necessarily rich countries. So an example of this is the United Nations Millennium Goals, right? These were put out in the year 2000, and they're indices of human health and well-being. So, these are goals that the UN wanted to achieve by 2015. Some of them are close, but even achieving any of these goals is only getting 50% of a population up to these standards, of no hunger and clean water and maternal health, etc. Right? And so if we look at these goals through an engineering lens, you can see that a number of them could involve an engineering intervention, right? You can think about new technologies for farming that can help eradicate hunger. You can think about health technologies that improve maternal health, right? You can even think of technologies like the Khan Academy, right, that can help kids learn subjects that they may not be able to get in their local schools. So this really shows me that there's huge opportunity for engineers to affect millions, if not billions of people, often in life or death ways. And these problems are by and large solved here, but they're not in developing and emerging markets because our solutions here are either too expensive or not reliable, or we can't get them over there or whatever. The second point is that your consumers in these markets are really different than those of us who have at least grown up in the US or Europe. Right? They may have different preferences for their products. They may have different daily life activities that you or I don't do. So, I don't think any of us went out this morning and collected firewood to cook our meals, right? But that's a really common thing for people to do in developing countries. This farmer who's using a tractor here, he's going to use that tractor 50% of its time for activities other than farming. right? He's going to schlep his friends around. He's going to bring crops to market. He'll do odd jobs to make more money. And that affects how you design that tractor. You know, hours used per year in a place like India for tractors is way higher than a place like the US. And then this would terrify our government if we saw people cruising around, you know, little kid just hanging off the side in his mom's arms. But that's a normal family, you know, transportation option in a place like India. Like, that's totally normal. And you have to think about, like, why would this guy choose a motorcycle? Yeah, he's putting his family at risk, but a motorcycle is cheaper to operate than a car, uses less gas. And if you live in a country where there's a lot of traffic congestion, you might be able to weave through it with the motorcycle and get from point A to point B faster, right? And he might prioritize that over, you know, perceived safety risks. So these are the type of things that we need to understand for these different type of consumers. And then finally, if you hit it right, if you make a product right, I think there's massive multi-market global opportunities for new products, for innovative new technologies that we may create for emerging markets, but then can be disseminated globally. And the canonical example here, and you're going to read a case study about this later on in the semester, is GE's ultrasound machine. So the story behind this is that in the early 2000s, GE was trying to sell stuff to China. You know, they were selling their high-end $100,000 US version ultrasound machines, and really only the richest hospitals could buy them. They weren't really penetrating the market. And they knew if they didn't get a bigger foothold in the market, they'd just get taken over by a local company, like as far as market share, not bought out. So what GE realized that was so insightful is that the Chinese market was willing to accept 50% the performance of this machine if it costs 15% as much, right? And so you've got this like nonlinear scaling between price and performance, but they figured that out. And do you need a chair, by the way? Okay, I'm sorry. If you want to sit maybe on the windowsill over there, you could do that. I'm flattered by the turnout, by the way. We're going to have a lot of fun. This is a cool class. So anyway, GE had that perception. They figured out 15% the price for 50% the performance. They made that ultrasound, and it sold like hotcakes in China. GE Healthcare is now the biggest healthcare device provider in China. And it's really a Chinese company. They do like engineering and production all in China. But this device also opened up massive new markets around the world that also couldn't have afforded this big device. So examples like ambulance workers or rural health clinics, they could now afford an ultrasound machine, right? So I love this example because they, as engineers, had to read those unique requirements of the market and then had to engineer a very unique solution, you know, compared to this thing. The new versions of this, by the way, look like a big iPhone. You know, they're even smaller. They're pretty cool. Another example of multi-market opportunities is sometimes you can just have one good product, but you just have to tweak it a little bit for it to work in different markets. And the good example there is shampoo. And so Procter & Gamble, you know, this is the shampoo they make for us. This is the big Mondo Costco-sized, you know, Jugs O shampoo that you go buy, you know, and yeah, you know, it's kind of expensive. These might be $15 each, but they last for like 6 months. These don't sell well in poorer markets because one, there's a bigger upfront cost for the consumer, and then two, it takes up a bunch of space in your house, and three, like your cousin might come by and steal some shampoo and wash their hair, and so you might not get all the shampoo out of it. So what they figured out was that all they needed to do was package the shampoo differently, and they came up with these single serving use shampoo sachets. And so now there's as much shampoo sold by volume in developing countries as rich countries, but all they changed was the packaging, not the shampoo itself, right? I think that's super cool. You know, they figured that insight and cracked open a massive new market. So, you know, what I think we want to do in this class and what we want to think about is how do we engineer solutions for folks like this, but at the same time for folks like this, right? Like, I think, you know, when you talk about developing world type classes, we tend to focus right in at the bottom of the pyramid. But you have to remember that, you know, you look at China, India, Russia, Brazil, you know, the BRIC fast emerging economies, there's 1 billion new middle class consumers that weren't there a generation ago, right? They buy stuff. This is a shopping mall in India, right? These consumers buy a lot of stuff, but these guys could also use technology to get out of poverty and improve their lives. And so, we have to recognize that the emerging markets are projected, to grow very quickly. China, China's like, I think it's passed now the US is the biggest economy. And as far as like global market share, they're about 18% now. This was a couple years ago, but they're projected to be 41% by 2030. So like all the massive economic growth in the next 20 years, like in your professional lifetime, is in emerging markets. That's why we need to train engineers who know how to operate globally. So, and that's the whole premise for this class. How do we engineer products for a real global impact? This class and kind of this ethos of like how do you be an engineer, how do you engineer products for global markets, this is really the ethos behind my research group, which is called the Global Engineering and Research Lab, Gear Lab for short. Any Top Gear fans? The TV show? Yeah, you notice the font? Yeah, I'm a massive Top Gear fan. And I love that we can use Gear Lab, and our email address actually for the group is gearheads@mit.edu. But anyway, what we try to do in my group is bring together hardcore engineering science, engineering theory, the physics, the equations behind how technologies behave, and blend into that the really unique user-centered socioeconomic aspects of developing and emerging markets, and see, at that interplay what happens. How do we have to engineer things to meet those socioeconomic requirements, but don't water down the engineering, still be hardcore engineers? And by doing that, hopefully create simple, elegant solutions that have global impact and both have some cool science behind them and real-world impact. So we do this by making hardware. I'm a total gearhead. I like making hardware, and all the projects in my group are basically like motivated by a billion people who need some sort of technology, and we work on the engineering science and the technology and actually make the thing, make the prototypes of the things that can impact the real world. The research that we do is articulating how that technology behaves. The engineering relationships, how weight and power affect size and cost, and those engineering parameters that we can teach other engineers, and they can adapt our technology to their situations. And by figuring out those design rules, we often get some really cool scientific insight into like fundamental new scientific problems. And I'm going to show you some of those during the semester as well in some of the case studies we do. And then the final thing is we work really closely with stakeholders, and they're typically organizations that already know the markets we're working in and are positioned to manufacture and distribute at massive scale, right? We as academics, we're good at coming up with ideas, testing them, getting data, but we're not really good at making products, right? So we try to partner with the folks that can make and distribute at massive scale. And that extends on to the model of this class. You guys will all be working with the biggest players in their respective markets for the projects that you're doing. So some examples of stuff that we do is off-road all-terrain wheelchairs, both for the developing world and for richer markets. And we'll have a class on that, the Leverage Freedom Chair. We're doing high-performance but low-cost prosthetic limbs, which includes redesigning the most common prosthetic foot in the world. There's 24,000 of these given away a year, as well as making high-performance prosthetic knees that are totally passive but can still replicate natural human walking motion. We're doing drip irrigation systems to, instead of using flood irrigation, which you see in this picture, using drip, which just drips out the exact amount of water you need, requires about 60% less water than you would by flood irrigation. But to do that with low enough pressure and low enough power to make an off-grid system economically viable for a poor farmer, we have to make it low pressure, and we have to make these things really accurately regulate water. And our system works off how your lungs basically restrict fluid flow, which is kind of cool. It's a biologically inspired project. And we have a paper on this that you'll end up reading in the class. We do a lot of work on water purification, both on the consumer scale. This is kind of a Brita filter type product that's sold in India. It's called the Tata Swatch. And so we are working with them to improve the design of this product. And we're also doing village scale desalination systems that I think we've seen a disruptive opportunity where we can make a much cheaper off-grid system than what's currently available. And you'll hear some more about that this semester too. And then finally, Michael's project is working on a means of turbocharging single-cylinder diesel engines by adding, here's the engine, here's the turbocharger, and adding what we call an air capacitor as part of the intake manifold. And what that does is allow you to add the turbocharger, make more power, make a more efficient engine, and that could have big ramifications for applications like tractors, water pumps, rickshaws, generators, tons and tons of applications in emerging markets that currently use naturally aspirated and thus less efficient single-cylinder engines. But anyway, that's kind of the portfolio of what we do. So I want to start by asking, when you think about when you're going to go into your career and you're going to operate as an engineer, what sort of engineer do you want to be, right? Do you want to be this guy, right? I love just kind of thinking of this dude sitting in Ohio, being like, boy, I hear on the news that India has a very rapidly growing economy. I should design stuff for India. Hell no. This guy's not going to have any context. Dilbert's not going to have any context. And I like this picture too for you Office Space fans. But he's cloistered away in his office. He has no context. I also don't think you want to be like this. The kind of great white savior mentality you see a lot in developing technology now. You have the rich celebrity who sweeps into the poor country and gives the widgets away to the poor children. No, right? This is not a good model. I don't know. I think it's a little paternalistic. Yeah, I don't think you want to be that. I also don't think, how many of you did Engineers Without Borders? That's great. I really respect Engineers Without Borders. But the problem is, you don't respect Engineers Without Borders? Is that why you're shaking your head? The issue with Engineers, what's good about Engineers Without Borders is you have a 5-year commitment with the village. That's great. But as far as a development strategy, shipping fat gringos halfway across the world to dig ditches is not scalable or sustainable, right? Sorry, fat gringo. Sorry. But these kids, it's great. I'm sure they're getting a great experience. And the real impact of programs like this is on the students, right? And if you remember that, then they're wonderful programs. But if you want to impact 1 billion people, this is not a model that can scale up easily, right? Because if these guys taught a village how to do something and then that village goes and teaches 1,000 other villages, okay, maybe. But that's not the way the model works, right? So I don't think we want to be that type of engineer. I think we want to figure out how we can leverage our skill sets but contextualize them with developing world problems and leverage what we're good at. We're good at analysis and math and creativity, but I don't know anything about what it's like to wear a prosthetic limb every day in India. I didn't grow up like that. And I chose these pictures because I think they really show the exchange of information from different contexts that when blended together, the folks can make something better than each of them could have alone. So this is a picture of one of my former grad students who did some really wonderful dynamics work on a passive prosthetic knee. This is a conventional knee right now that's a locked joint. And you can see him, here's his dorky collar and his dorky notebooks, right? And he's walking around with this guy. And he's a whiz at dynamics, but he doesn't know a lick of anything about what it's like to wear a prosthetic limb every day. But this guy does. And even if this guy only has a 4th grade education, doesn't matter. He knows what it's like to be an amputee much more so than my student does. And so when they talk to each other, good things happen. This is a picture taken in India in a cotton field. And so here you have a farmer, you have one of the head engineers for the 2nd largest drip irrigation company in the world, and you have me and a grad student. Right? And so this conversation, the information that was flowing around there, that's good stuff. Right? We're all coming from different perspectives. And Pavel's probably doing calculations right here. He's talking about production. He's talking about water needs. And how oxen may step on his field and crush his irrigation equipment. All these things are really good. And I think it's maybe good to pause right here and think about how much of this experience can we give to you guys when you're constrained in having 1 semester in this class and you're not traveling, right? And so I want you guys to think about how you can gather as much contextual information as possible, even though you're going to be working here, and by and large your work is going to be engineering related. That's where I think your big value added is. And the reason we partner all the teams with companies and stuff is because they can bring context, right? You can learn a lot from them. And so you can bring some really nice value added, combine that with their context, and create some really nice things. And we'll show you some examples of that in a little bit too. So, the objective of the course is I want you guys to have a perspective on the technical and socioeconomic factors that are really important to designing technologies for developing and emerging markets. Like, these factors really affect these factors. And if you guys don't realize that, it's really easy to screw these up and then thus screw this up, right? So I want that interplay, that nice convergence to really be the theme of this course. Also, I designed this course to be a qualifier prep course. I'm not going to say it's like the be-all, end-all. Like, it will give you a lot of quals practice problems, and it'll help you think through the type of problems and solve the type of problems you'd see in both the machine design and product design courses. But we have a really nice array of design courses here, and if you love design, take them all. But this will give you a really nice set of practice problems, as well as your term-long project is very much in the vein of what we look for in the qualifying exams, both machine design and product design. And I serve on both of those exams. Okay, now I want to talk about like what specific skills do I think you guys need to get in order to engineer successfully in developing and emerging markets. So the first is that I think it's really, really important to define design requirements accurately up front. And we'll talk a lot about that, and you'll spend a good amount of time about that. So, here's an example of a product. This is called the Life Straw. And it was initially designed for people who contract a type of worm out of surface water that they drink. And it worked pretty effectively for that. But when you look at this picture and that person using the straw, how do you feel about this picture when I put that picture next to it? Right? Like, that's kind of uncomfortable, isn't it? So like, the point here is that this thing could purify water perfectly. But if you look like a dog using it, people may not want to accept it. Right? And so we need to think about that as engineers designing for this space. The second is that we need to understand the unique consumers and market dynamics of developing and emerging markets. So what's this a picture of? Yeah, it's a slum, right? What do you see on the roof? Yeah, right? Satellite dishes, like next to mud huts or slums, right? So this should give you some insight into like how these people are allocating their income and what they're prioritizing. So like, one of the themes that you hear all the time in development technology is like, let's make low-cost housing. Let's make a $300 house. Actually, one of our speakers coming has written like articles about the $300 house, and I have a lot of issues with it. Because you got to think about why. You have to ask yourself, why would that family spend $300 on that house? What's the incentive there? What's the return on investment? Right? With TV or like alcohol, that's a pretty quick return on investment. It's really clear. Put your money out, you get something back. And like, if you're kind of living in this community where you may not have a lot of other entertainment, TV is pretty awesome, right? So you got to think about like, why would a person spend money on maybe clean water when, unless they're dead, they've gotten clean enough water their whole life to not die, right? So, and they've probably gotten it for free. So then if you ask them, oh, buy this widget that makes clean water, that, by the way, you probably can't taste the difference. Like, what's the return on investment for that? So we have to think about that. Why do people spend their money? What do they prioritize? You need to remember that, like, user-centered design is really good about talking about the end user and trying to empathize with them and think, put yourself in their mindset. And that's something that we have to do too. That's really important. If you're designing for this guy, you want to learn as much as you can and try to interact with that guy. But you also have to remember there's a whole chain of stakeholders that you need to link together in order to get a successful idea all the way to market. Right? So it could be like, big manufacturing constraints. Like, how could you actually make something in a context? It could be, big corporate like missions and objectives, right? And you may have to appeal to them, right? This is a picture of Ratan Tata, who headed Tata, one of the big multinational emerging market conglomerates for about 25 years. He just retired 2 years ago. So you have to remember there's a whole bunch of stakeholders, and if any of those links in the chain breaks, your technology might not get out to market. And then finally, we're going to talk, and we're going to actually read the book, Reverse Innovation, but this idea that when you design technologies for emerging markets, you often have to achieve high performance at low cost, right? Like the GE ultrasound machine example I gave before. And so you end up making really high value products. And I show this wheelchair up here because when we started this wheelchair project, off-road all-terrain wheelchairs cost $4,500 to $7,500, way outside the price point of emerging markets. We had to make a $200 chair that would meet the price points and could operate off-road. And then all of a sudden, people in the US, in Canada, and Europe were like, hey, we want a cheap off-road wheelchair too. And that actually has driven us to make a US version, which we're launching this fall. Here's one of the guys from our company riding off-road, and I think this is the Fells in Somerville. So anyway, the point here is that if you can create high performance but low cost and high value products, you may be able to engage global economies. And that's super exciting. And that's really a core tenet of what we're trying to do in my research group. Yeah, we're trying to help the billion people in poor countries, but if that leads to like the technology the military can use after, awesome. Really try to disrupt global markets. Okay, so now let's talk about what this class is going to contain through the semester. The first is we're going to do a bunch of lectures, obviously, but the content we're going to cover is some design process work. We're going to talk about, I refer to top-down versus bottom-up design work. So what I mean by that is bottom-up would be you take a big problem, you break it down into small parts that you can figure out one at a time and build it up to a final solution. But you have to balance that with maintaining the top-down view of thinking about how will this technology operate in the real world? How will it interact with real users when it's finished? And so we'll talk about leveraging design freedoms, which I mean are elements of the environment you're designing in that you can take advantage of and use and exploit, and also how to engage with stakeholders effectively. We're going to take a product and machine design view of technology. So we're going to talk a lot about user-centered stuff, but we're also going to dive into the physics of a bunch of technologies. We're going to try to understand the important socioeconomic factors of developing in emerging markets and do that through a few different lenses, like development economics and business innovation, as well as engineering. We're going to look at the physics behind a number of technologies. And this is, we're getting into a lot of qual stuff here. And then I'm going to introduce these little kind of snippets, I guess, or subsections of lectures, which I call your engineer's toolbox. And these are just like nuggets of engineering theory that if you have in your back pocket and can like whip them out, they're really, really useful. So this is part of your quals prep too, and I weave these into a number of the examples that we'll do. We're also going to do a whole ton of case studies looking at actual developing world products. And we're going to run the gamut from like technologies focused on the poorest of the poor, like the Jaipur foot, which is given away, or a wheelchair, to technologies that are sold to the masses, like the Honda Super Cub, to, we're going to talk about the GE ultrasound machine that I told you about, the highest selling cell phone in history, all the way up to the Kalashnikov, AK-47. Anybody know how many of these have been sold ever or disseminated? I'll give you a hint. There's been 250 million of these. The Nokia 1100 cell phones. This is the cell phone that cracked open emerging markets. How many of these do you think have been sold? 600 million? No, it's not more, but it's 175. It's a lot, and I'm not trying to laud, the killing efficacy of this thing, but like as far as a complicated multi-part machine that's mass produced, there's a lot we can learn from this as engineers, and how it works in emerging markets. So the MIT's chief of police is going to come and give a talk on this. He was the arms expert for the Mass State Police for many, many years. He knows everything you could ever want to or not want to know about the AK-47. But that's one of my favorite lectures. It's pretty cool. We're also going to do some demos and experiments. So you guys are going to be playing with human-powered water pumps and looking at the physics behind these and actually thinking through like how much could you actually irrigate with these systems. You know, these technologies have been lauded as this low-cost intervention which can enable farmers to irrigate. But you as engineers should ask, how much can you irrigate with human power? Right? We're limited in what we can do. We're actually, as animals go, we're pretty wimpy. We're also going to do a module on cook stoves where you guys are going to test a bunch of different cook stoves and see the performance of those. We're going to do some product teardowns. So we have a bunch of developing world products that you're going to rip apart and look at the physics behind them and look at the manufacturing behind them. This is a really fun exercise. And look at the socioeconomic and kind of user-centered factors behind them. So I just want to show you a quick video of the Tata Swatch, which will be one of them.
चांदी की इसी क्षमता को और भी बेहतर किया है टाटा स्वच्छ की अत्याधुनिक नैनो टेक्नोलॉजी ने। ये छोटे से छोटे कीटाणु को मारे और दे आपको पानी जो हो सचमुच स्वच्छ।
ये नए जमाने की चांदी है जो सचमुच स्वच्छ पानी देती है।
टाटा स्वच्छ।
That commercial is dripping with aspirational aspects, right? So that product, just to give you some backstory, that product was designed kind of as a water purifier for the masses, largely targeted at poor families. Does that family look poor? Like, no, they're pretty affluent. Another funny thing about it is it says, well, they highlight nanotechnology, so that's all the rage, right? But they also say silver nanoparticles. And they did that very intentionally. There is silver nanoparticles in it to kill viruses. But they said they really highlighted the silver part because of how precious metals are valued in India, right? You know, a lot of Indian families, you know, they'll wear bangles or buy jewelry, and so precious metals is a big thing. So I love that commercial. It's got all sorts of fun socioeconomic aspects. Okay, we're also going to read excerpts from some of, these are all actually quite, well, this one's not super new, but the rest are quite new books. And all of these touch on engineering certainly, and touch on products, but I wouldn't say they're engineering texts. You know, one of the reasons I do this course and one of the reasons I do my research is eventually I want to write the kind of engineer's book for this space. Like, how do engineers operate globally? How do we do that? But for now, I think we have to pull from kind of these overlapping orbit fields and see, like, what can we learn from them? So Hidden in Plain Sight is a book on ethnographic research and trying to discover user needs by working in the field. Poor Economics is a book about development economics, and this gives all sorts of cool insight into how we can design better products. Reverse Innovation is about business innovation in developing and emerging markets, and mostly focuses on large-scale multinationals. And then Out of Poverty is more, I would say, a grassroots focus, but still large scale. You know, one of the tenets in here is like never work on a problem that won't affect at least 1 million people. Right? And the guy who wrote it, Paul Pollock, started IDE, International Development Enterprises, which has put out, you know, well over 1 million treadle pumps, and I would say they're the most successful development NGO technology type firm in existence. So this is a really nice set of books, and please go on Amazon right now and order these so you can start reading them. We'll start this one next week, I think. It's in the syllabus. Two other books that I just recommend that any of you as engineers should have on your bookshelf is Shigley and Mischke's Mechanical Design and Mark's Standard Handbook for Mechanical Engineers. This has a lot of the kind of nitty-gritty engineering theory that would be commonly used, you know, like bearing life and gear tooth stresses and all this stuff. And this is just a nice repository. Like if you want to go look up, you know, what's the coefficient of rolling resistance of a tractor tire on dirt, it's in there. You know, it's cool. And like, how would you size your ducting for your AC system? Well, it's in there. But I have these on my desk, and I, you know, refer to them all the time. We're also going to have a whole bunch of guest speakers. And I try to bring in guest speakers who are all like global leaders in their aspects of development technology, you know, more so than I am in each of their individual aspects. And I think they're really they really tell a good story, and they can really connect like what you're thinking about as an engineer to what they do. So our first one's going to be Shashi from Light, which is a new, I guess I'd characterize it as kind of a startup incubator that's part of Lawrence Berkeley National Labs and UC Berkeley. But this guy is a visionary as far as like what development technology can be, how it can impact people, and he just compiled a report of like the 50 most compelling technological needs right now facing developing countries. They did this huge comprehensive study, and this is a great starting point, I think, for a lot of us who want to go work in this field. So he's coming in a few weeks. Vijay Govindarajan, who wrote the book Reverse Innovation, has become a good friend. And so we do kind of a horse trading every year. I go up to his class and he comes to mine. But he'll be here in early October and talking about business innovation in emerging markets. Ratan Tata is going to come, which is pretty cool, right? He's kind of like the Tony Stark of India. He's this like billionaire, like super successful guy. He's the nicest guy too. I have marked on our syllabus potential dates he might be here. We're still working out, but he is coming, and he already said he's coming to this class. So you guys are going to have a private audience with him, which is really cool. Rebecca Richards-Cordum is one of the top academics in the US that does development technology and has it as one of the core focuses of her research group. She does a lot of diagnostics technology for developing and emerging markets. So she'll be coming in November. She'll be doing a class session with us, and then she'll also be speaking in the Tata Pro Seminar. So the Tata Center for Technology and Design, how many of you are Tata Fellows actually? Only one. Wow. Yeah, that's disappointing. But anyway. The Tata Center, for those of you who are interested in this stuff for next year or whenever, the Tata Center was set up by the Tata Trust, which is now run by Mr. Tata. And they gave $60 million to MIT 2 years ago to start the Tata Center for Technology and Design. And the focus of this center is to create technological solutions for emerging India. So we have 50 grad students now sponsored every year through this program. Sponsors your tuition, stipend, health insurance, whole deal, to focus your graduate level research on emerging India challenges. Pretty awesome, right? So she's going to talk in the seminar that we do with that. It'll be a institute-wide advertised thing. So will Shashi, by the way, the first guy I showed you. And then I'm 99% positive Bob's coming. Bob's a good friend of mine who's the chief mechanical engineer for GE Healthcare. Right? GE Healthcare is a juggernaut. They're like $13 billion a year in revenue or something. Massive global reach of health technology.